Good afternoon. My name is Murray Southwell. I'm currently the manager of the network platform team within TASMANET. I've been with the company since it started as a wireless ISP in 2014. I can see there's a couple of other people in the room that were also involved in the company back then, which is good to see. During the startup phase, we quickly realised the potential for the business market and quickly moved into predominantly business activities, especially multi-site managed private network solutions for people. We tended to specialise in the hard-to-do locations which are beyond the reach of currently available broadband, which back then wasn't a whole lot in Tasmania, I must say. This meant we built pretty much all of our own network. Very early on we discovered MikroTik and started using not only their routing platform but also the wireless side of it. Our mainstay for many years back then was fully meshed, resilient, managed private networks for clients that didn't rely on fixed line infrastructure. We had lots of clients that had fixed line infrastructure. We also provided redundant paths for a lot of those clients. Picked up a lot of business there. Since then we've progressed a bit. We've laid our own fibre footprint around Hobart, which we use for high-speed customer connections, inter-DC connections, NBN POI, Telstra Exchange, connectivity for ourselves, etc. At the same time, we built a data centre in Hobart. DC3 has room for 90 racks, which is not very big, but by Hobart standards, a reasonable size. Stage 1's only got a couple of free racks at this point, and the second pod is going to have to start building out pretty soon. Since 2013, we started transitioning from a purely telco-based company to a full digital services provider, delivering products as a service, including our premium private cloud offering. This is currently utilised by a range of customers right through from SMEs to government departments. While building the private cloud offering, we quickly realised the benefits of software-defined networking, and we've invested fairly significantly in this platform over the last few years, and we're actually now starting to retire legacy MPLS-based networks in favour of SDN. While we're based in Hobart, we've got regional offices in Launceston and Burnie, and currently have just a little over 40 full-time employees. Now, the technical part of this presentation was actually put together by one of our senior network engineers, Phil Leica, and I'm going to hand over to him for the technical part of the presentation and to answer any of the really technical questions you might have at the end.
All right. You want to take your laptop, Murray? All right, so this presentation is about the NBN, how we have used it in the past and how we're using it now. Is the sound okay? Everyone can hear me okay with this one? Cool. All right, many of you would be familiar with NBN. Hang on. Unhappy mic. Is that better? I think the phone bit was just coming off. All right, yeah, many of you would be familiar with the NBN. We have the joy of a multiple technology mix thanks to various political decisions, including fibre to the premises, fibre to the node or building, fixed wireless, HFC and satellite. Satellite is a bit of a black sheep, treated quite differently from all the others. We don't have any satellite services, and you may not be surprised to know we don't have any HFC services either. So any of the things I cover may not be relevant for those services, but it should hopefully apply. A lot of this stuff as well would apply to other connectivity methods because I'm talking about things like IP addressing and interfaces that you may find some useful information even if you don't use any NBN services. The NBN deliver services to their 121 points of interconnect around the country, so they're all region-based. If you have an NBN service in Hobart, you have to have be connected to their point of interconnect in Hobart to be able to actually do anything with that service. Same in Launceston, so we only have the 2 in Tasmania, and there's 119 around the rest of the country. They present the services using 802.1 AD. You may be familiar with Q&Q or double-tagged VLANs. So you get the CVC part of it is delivered as the outer VLAN tag, and then each individual service is presented as a VLAN within that, allowing up to 4,000 services per outer VLAN. My favourite part about the whole NBN design is the fact you get nearly complete layer 2 access across all the services. Once you've actually got your connectivity in place, whether you need a VDSL modem or you just need the NTD on the wall, you can then use many layer 2 protocols. For example, the MikroTik neighbour discovery works across those services. You can set up routing protocols such as OSPF, BGP, and all sorts of things like that. That makes it really easy to send out a router with a base config, like just that we have on the shelf, and once it's out on site, we can then remotely connect in and configure it. We have various challenges as part of provisioning these NBN services. Some of these may be the same as challenges you guys face. Some are possibly unique to TASMANET. But hopefully, again, you'll find something useful in amongst the information I provide about them. One of the frustrations we've had with it is that NBN have a policy of not allowing you to fully bridge NBN connections together. So you can't have one customer service, full layer 2 connectivity to another one. If NBN see traffic from a MAC address coming from a CPE on one service, handing off at your NNI, then that same MAC address being seen entering the NNI, then they may shut down the NNI. And that includes every NBN service on that interface. So it can cause a lot of pain for a lot of people, so it's something we have to be very, very careful of. Another thing the NBN have in place is they have very strict policing on their traffic. Whether you buy a 25 meg service or a gigabit service, doesn't matter. They only allow you to burst above your paid speed for up to 10 milliseconds. After that, they will police the traffic. In other words, just drop packets flat out. This causes some very bad internet performance if you don't have shaping correctly configured on the services. Another feature that we at TASMANET require as part of our business use cases is we need to manage contention between different services and different contention levels. So we have different groups of customers, business customers, home customers, corporate customers, and so on, and we have different contention ratios for each of those groups. So we need to be able to actually manage that in a way that doesn't make us go insane, constantly tweaking numbers. Another option as part of setting up NBN services is how we actually deliver the services. PPPoE used to be the standard used for a lot of connections, such as ADSL. It has some benefits. For example, you can optimise your IP address space usage because you allocate a /32 IP address effectively. It's also very easy to see when an NBN connection is up or down, and accounting is built into the PPPoE design so that if you need to monitor quotas and so on, most billing systems will automatically read that information and take it into account. But some of the negatives of PPPoE are that you have to configure the actual PPPoE session. That's a unique configuration on every CPE, and there are extra overheads for that as well in CPU usage on both the CPE and the BNG in our data centre. IPoE has become a lot more popular lately. It's much simpler to configure because you can literally have 100 CPEs all configured exactly the same. You plug them in, they use DHCP and get a connection. We don't have to worry about usernames and passwords. If a customer changes a password, you don't have to talk them through changing the password on their individual router, which I'm sure many of you would have had some fun trying to actually talk them through the various different models and makes around the place. It's also very useful in that if a customer is trying to troubleshoot their connection, if they happen to have a fibre to the premises connection or a fixed wireless connection where you've got an NTD, then they can plug a computer directly into the Ethernet port and their computer will get DHCP, and you can then identify whether the issue is with the router or whether it's with something further upstream. It also lets you use a higher MTU for the services because you don't have the overheads of the PPPoE headers. However, it is harder to determine if a connection is up or not. Effectively, you only have the DHCP lease or monitoring for traffic on the service. And accounting over IPoE connections is not a common feature in products. For example, MikroTik don't actually support that directly. However, there is a way around that. Many of you are probably cringing that I've got even static written there at all. However, there are some use cases for it. And as I mentioned before, the fact that you get a layer 2 connection means you can run things like routing protocols over these services. So if you do need to set up OSPF or BGP, I don't think you'd want to have a DHCP client on that interface handling that connection. Another challenge we have, which I covered a little bit in PPPoE, is you need to optimise your IP address utilisation. IPv4 is like gold at the moment. Getting more addresses is getting more expensive all the time. So making sure that we don't waste IP addresses is very important. And common things here too, authentication is important. You need to know who a customer is, especially so that you can match up any queues that you've got and any accounting information for them. Accounting is important. Some people don't have quotas on NBN plans. The current range of TASMANET NBN plans actually don't have any quotas on them. However, there are some data retention requirements around that. And lastly, automation. It's very, very easy to make mistakes when you're just doing repetitive tasks over and over again. Automation makes things a lot quicker and a lot more consistent. So we tried a few different designs early on when we started using NBN. The first BNG we actually used was a MikroTik Cloud Core. I believe it was a 1036. And this was in the days before Router OS 6.35, which is important, which I'll explain later. We had all of the connections, hopefully you can see it reasonably clearly there. Have an interface facing the NBN. This is actually a screenshot from a lab that I did. This design we haven't used for several years, so I just mocked it up on a CHR. So we've got the NBN connection coming in here, you can see on the first picture, with the C tags or the customer services underneath that. And then we bridge them all together. Bridging them, as I said before, is dangerous. However, there is the split horizon bridge function, which you can just see there has horizon 1 on there. By using the horizon function, if it's set to anything other than blank or 0, the interfaces that have that set can't talk to each other. So if you have 2 NBN services as part of the bridge with the horizon set to 1, they can talk to the BNG, but they can't talk to each other, so the traffic doesn't end up going back into the NNI and causing NBN to potentially shut down our link. And then we've got queues on the right-hand side there. So we've got a range of speeds under NBN. Again, this is just a sample that I just threw together on a test router. But those queues are the part that caused us pain. Unfortunately, NBN's policing restrictions, them policing it down to 10 milliseconds, was not something that the MikroTik router could handle very well. The traffic kept on bursting above that, and NBN were dropping packets. To explain what happens when we do this, I made a very quick little diagram here. TCP congestion management is the part that is causing the pain. When TCP is sending traffic, it keeps on ramping up to try and find the speed, the maximum speed that it can transmit at. In a normal situation, it'll get to a point where it'll flatten out. However, when packets get dropped, it halves the throughput for that traffic. So as soon as it goes more than 10 milliseconds over the purchased rate for the NBN connection, the speed drops dramatically. Then it's got all this headroom, so it keeps on increasing speed again, and you end up with this sawtooth pattern. In doing some tests on some customer services, a 25 megabit NBN connection tended to get speed tests around the 14 megabits a second because of the ups and downs of that traffic flow. Just checking where I'm up to here. All right, so that was the first router that we used. As part of querying some of our peers in the industry, one of the recommendations was that you needed a device that could do the shaping in hardware, which the MikroTiks don't do. So we were looking around at various options, and before spending any money, we thought we'd try it on a switch. Now, we never intended to put this into production, just for the record. Obviously, switches are not suitable for this. We found that the hardware shaping worked really, really well. It did keep the traffic from bursting for more than the 10 milliseconds, so we got much better, more consistent speeds across those services. However, it's not designed for this role, so we could only actually, on the particular switch that we tested on, we could only do the correct shaping for up to 8 services on a single device. And having one switch for every 8 services obviously is not a sustainable thing. So it was no shock to anyone that switches are not routers and not aggregation routers, or at least not at this level. However, as a little side note, it did actually help us to get through the certification at the NBN test facility, because you only have 4 services that you need to actually have up and running. So then we decided to invest some money in a product that some people recommended, the Cisco ASR platform, and utilising the ISG part of that, Internet Services Gateway. Now, we do have experience with Cisco in TASMANET. We do have some other devices and so on around. However, the ISG part of that was new to us, and I have to admit that when first reading through how it all fit together, it looked something like this, like the Matrix, trying to work out what on earth it all meant. I spent a lot of time reading up on it and so on, and eventually got to the point where I understood it. However, I still didn't get to see the blonde, the brunette, or the redhead that I think it was Tank got to see in the Matrix. So the ASR did a really good job of the traffic shaping. It even handled accounting for these IPoE sessions, which not many devices handle. However, it has some issues, not just the cost of the devices, which is significantly higher than a MikroTik type device, maintenance and so on, having to have service contracts on them, and making sure staff had suitable training was also a bit of a headache. But we also had some strange functionality issues on them. For starters, the DHCP server, when you have it using a radius server for handling for working out what IP address to give out to a service, you have to give it a maximum lease time in the radius response results. And while that is probably a common thing, you always have a maximum lease time, the Cisco had to force the DHCP lease to disconnect, like to release it completely at the end of that window, which meant that every time the DHCP lease expired, everyone's connection dropped for several seconds while it renewed and got a new IP address. So you can imagine the complaints that we had for that, particularly for people with VoIP phones and the like. And we actually ended up, instead of using the DHCP server on the ASR, we set up a MikroTik as a DHCP server and configured the DHCP relay on the ASR, which worked much better, got rid of that problem. We did consider increasing the length of the DHCP lease to be longer so that we didn't have that issue. However, that introduced another issue where if a customer changes to a different CPE, then they have to wait for the DHCP lease to expire, or we have to manually go in and release the DHCP lease. That was actually still an issue when we used the MikroTik DHCP server as well. Another issue with the ASR, at least the models that we had, is that you could only have one IP address routed to each ISG session. This includes both IPv4 and IPv6. So it means we couldn't give additional IP addresses to customers that requested it, which we get from time to time. And it also means we couldn't do dual stack with IPv4 and v6 on those sessions. So we had that running for quite a while, and then MikroTik released RouterOS 6.35, which, as I mentioned before, was a quite significant release for us. They introduced a feature called bucket size. To understand what that does, I'll just bring up this is the workflow that you can see on the MikroTik wiki, showing how the traffic shaping works on the MikroTik routers. So it's lots of little components there, but the parts I want to point out are down there in the red box that just highlighted is where it hands off the traffic to the interface. The green box up here is where it does the rate limiting. And as you can see, there's a few items in between those steps, and they are the token buckets. Those token buckets mean that even if you don't have bursting configured on your queues on the MikroTik, those buckets will still empty at the full rate that they can to the interface. So you'll end up with bursting from those buckets. By changing the bucket size value, which I showed on the previous slide, let's go back there. So you can see the line in the lower section there. By reducing that value, it shrinks the bucket down, and we were able to configure it to a point where the bursting from emptying those buckets was within the NBN thresholds. So despite everyone saying that you needed to have a hardware shaping solution to be able to meet the NBN requirements, MikroTik showed everyone how to do it properly. So I'll now run through how we currently have our connections set up. There's a few issues that we had with the way things were then. Sorry, I've been going from memory for most of my notes, and so I have to make sure I catch up to where I am on the bits of paper I've got here. That system that we had there with the MikroTik running at least RouterOS 6.35 was working really well. It still had a few issues, one of which was we were still using the bridge. And the problem with the bridge is if someone stuffs up, then we end up with a full bridge between services, and NBN could shut down our NBN connections. There was also, by having them all bridged together, we had a lot of broadcast traffic going between all of the services. So whenever a DHCP client requests an IP, for example, if the response is a broadcast, the response goes to every connection on the bridge. So our current method, now this, it does include some things that we were already doing before, but basically I'm running through all of the components, regardless of whether they were new or old, just so you can see the full picture of how we have it. This is a very rough diagram. There's not really any detail in that, but I'm going to go through and explain detail in the future slides. First of all, the biggest change was on those interfaces. We got rid of the bridge. That meant we got rid of those broadcasts, and there was no risk of accidentally creating a full bridge between the interfaces, which would give everyone a headache. We're also using proxy ARP on those interfaces, which means that if a customer wants to talk to well, I should have actually had this note a bit later in the presentation. Proxy ARP it's an old feature. It's been around for quite a while. Effectively, it allows the router to respond to all ARP requests with its own MAC address. This means regardless of whether a device is trying to do layer 2 or layer 3 traffic across the interface, it will effectively intercept it and route the traffic. So if traffic was coming in one interface and proxy ARP responded to it and traffic was destined out another interface on the same router, the source MAC address of that traffic becomes the MikroTik router. And we're using IPoE for these sessions. We have actually been using IPoE from the start as a very conscious decision because PPPoE has a lot of extra overhead that we didn't want to deal with. But that means IP addressing can be a real pain in the butt if we did it the old way. We'd burn at least 3 IP addresses if we had a /30 on every interface, one for network, one for broadcast, and repeating the router, the gateway IP on each individual one. This is a sample of our IP address lists on one of our routers. Every single one of them is a /32 address, and every one of them is the same IP address. So in this case, we're using the first of our real-world IPs, 120.29.240.1, and the network address, instead of being the same IP, is the IP that we are giving out to that individual customer service. This puts those network addresses into the routing table and allows us to advertise those individual /32 IP addresses via BGP out to our core and transit routers. By having them as /32 IP addresses, it also means that they are fully portable addresses in that we can have 2 contiguous IP addresses on completely different routers and not have to worry about net masks and so on causing any routing issues. We also, because we have all these interfaces, instead of having one DHCP server on the bridge, we have one DHCP server per interface for every single NBN connection. It does look a bit messy, but it does also have a really neat side benefit that if there are any DHCP events in the log, it actually says the name of it, which means we know exactly which interface it's coming from. When a CPE on the end of an NBN connection sends a DHCP request, the NBN equipment injects DHCP option 82 into that request. I think it's commonly called a circuit ID. In this case, they put in the unique service identifier, being an AVC number, and based on that, we send the request to our radius server. The radius server reads that AVC and responds with the IP address matching the service. One of the really neat things about MikroTik DHCP servers is that radius overrules any DHCP lease. That means that if a customer has a DHCP lease for, say, 24 hours with one CPE and they swap over their CPE, when the DHCP request hits the MikroTik router, it forwards to radius, gets an IP address that's already in use. The MikroTik router, because radius takes precedence, it will automatically delete the old lease and create the new one. So this means no more calls from people saying, I've changed my router and it's not working. Now, in talking about our radius server, we use a product called Flinx. We primarily use the Internet Services Management function of it. It does have some other bits and pieces, but yeah, basically we use the radius server and it has some really neat MikroTik queue management functionality in it. Flinx, along with the other products we use, there are other products that would most likely do the job for a lot of this. However, these work for us, and when we, for all of the products we're using, one of the key requirements is that they all have support for an API, which will be very important as we get later on in the slides. Queues. Now, there's a really good presentation from the, where is it? In the MUM Europe, just this year, there was a presentation done by Alex Vishnyakov called MikroTik Bandwidth Manager, and he compares different queue types. And we were already doing this particular queue type, but the summary is that having nested simple queues, as you can see here, hopefully you can make out some of the details, is the most effective queue type when you have a lot of queues. It has the least impact on CPU. As you can see there, they are nested. We have the top level queues are our contention groups. So we have 4 of them at the moment, covering home office connections, business connections of various levels. Underneath each of those is a queue per tariff. So if we have 25 meg connections, they get grouped under one lot, 50 meg connections under another, 100 meg under another, and so on. And underneath each of those is the individual queue for the specific NBN service. Now, as you can imagine, it would be a pain in the neck to create all those manually, and you may notice by the names that it doesn't look like we actually did. That's because one of the best features we've found in Flinx is it uses the MikroTik API to routinely connect to our routers and will configure all these queues for us. It is zero touch from the point of view of our support staff. That covers all the products that we're using, except for one. As I mentioned, automation is very important. Nobody wants to have to create all of these things manually. You can spend a lot of time that it is better spent doing other things. Automation not only brings benefits in terms of speed, but also cost and accuracy for provisioning all these services. The key product that we use for automating all of this is called ServiceNow. You may be familiar with it. Again, it's a product we were already using. So there may be other options out there, and I know that some people do their own in-house applications to go and perform all this kind of automation. However, for us, it was a case of, we've got a product already, it works, there's no point reinventing the wheel for those. ServiceNow, now, for the record, we are almost there in terms of full automation. We do have a little bit to go, but the end result, which will hopefully be not too far away, is that ServiceNow is the only system that our service delivery staff will need to use to get an NBN service online. So the first step it has, so that is actually a fairly accurate workflow. I'm sure you can't see the details, but all that branching and so on is the actual workflow that we're using for provisioning NBN services. The first thing ServiceNow does, or will do rather, is the one part that we actually don't have finalised yet. It connects to the NBN using the NBN B2B system, which uses EBXML to do pretty much anything you can do in the NBN portal. I'm sure there are some things you can't do, but for us, it'll do everything we need. This includes ordering the actual service and then checking to see the status of that order so that we know when it's actually been completed by NBN. We use a product called NetBox for our IPAM and also for recording lots of other information. As I mentioned, one of the requirements of these products that we chose is that they have an API. So ServiceNow can talk to NetBox, query some pools of IP addresses, find the next available, allocate it to the NBN service, mark it as used and so on, and record it for the next steps. NetBox has a lot of other functionality. If you haven't seen it, then it may be worth taking a look. You can record all sorts of information about what's in your racks and so on as well. As I mentioned, we use Flinx, and it has an API. The great thing about Flinx is it has an API for ServiceNow to control Flinx. We use it to create an internet service, or sorry, rather create the customer first, then create the internet service underneath that, and then Flinx, because of its automation, will then go and create the queues on the appropriate router. There are some parts that we don't have other products to do, but thankfully ServiceNow is flexible enough to connect to arbitrary devices and run commands. So ServiceNow then connects out to the MikroTik that is providing the service, creates the interface, assigns an IP address, the /32 address, to the interface, and configures the DHCP server. All going well, assuming that there is already all the necessary NBN equipment in place, most services can be set up within about 20 minutes of entering it into ServiceNow. I have heard reports that it can be as low as 2 minutes. Most of that delay is actually NBN provisioning the service. We generally allow at least 20 minutes from placing an order for stuff to happen, and sometimes it can be hours depending on various maintenance that NBN are doing. So that's how we're providing NBN services. We do have a few other bits and pieces. As I mentioned before, you get layer 2 access across NBN. So we have even spun up MPLS across NBN services. We've done it over fibre to the premises and fixed wireless. We tried to do it over fibre to the node as well. However, the routers that we had only handled an MTU up to 1500 bytes, so it didn't handle the extra overhead of the labels very well. Just a note too, the MTU across the various NBN services, they do vary a little bit. The highest is being on the fibre to the prem services, but all of them, as far as I'm aware, discounting satellite and HFC, handle at least the 1500 byte packets that is generally expected across an internet connection. IPv6. Everyone has to get there eventually. We have been making some headway with IPv6. Unfortunately, RouterOS has a few missing features that we would like to see come sooner rather than later in that space, including the support for DHCP v6 prefix delegation from radius, so that we can actually account for that rather than having dynamic IPv6 address space. Flinx also only has partial support for IPv6. You can put in IPv6 addresses, however, it's missing some things like adding those IPv6 networks to the queues for those customers. So it does mean that customers can have unqueued traffic, which can cause some performance issues. And one of my favourite things from MikroTik over recent times has been the CHR. We've used them quite extensively. We do have quite a few production CHRs on our network, but we also use them heavily in labs. We use EVNG. I know some people use it in GNS3 as well, which is a similar product, to create a network and do testing of the various features within the MikroTik. On my laptop here, I've just installed Hyper-V as part of the Windows 10 and run CHRs on there as well. And obviously VMware and KVM and so on are also supported. I know there was a mention in the last session about that it's very cheap to go and get some of the smaller MikroTik devices to do testing and so on. But hey, if you get a CHR, it's free. The main limitation you have to be aware of there is that if you're running the free version of it, you can only have up to 1 megabit a second transfer on each interface. But you can get a free trial of, I think it's up to 60 days at the various license levels. Like most things in the IT industry, our designs for how we're currently doing NBN are not things that we came up with all by ourselves. It's a very collaborative group that we have, so I have to give credit where it's due. Terry Sweetser, who I haven't seen here today, but he started a conversation on the MikroTik Australia mailing list a while back, discussing about the, how to do some IP addressing on NBN connections, and he actually came up with the idea of, or at least as far as I'm aware, of putting the /32 IP addresses on the interfaces. So we then did some testing based on that and found that it was actually really awesome. He never mentioned about the benefit of being able to advertise them out as /32 addresses on BGP, making the addresses portable like we do, but I'm sure he's probably making use of that by now as well. Another person we've done a lot of collaboration with is a guy who's in the room today, Damien Ivory from Lontel. We have a business relationship between TASMANET and Lontel, and we get to do a lot of collaboration, and so we've had a lot of discussions and comparing notes and so on how we do various bits and pieces. And of course MikroTik. The amount of features that continuously get released is always a surprise to me. As I mentioned before, the Cisco ASR, for example, one of the biggest costs is the maintenance. If you don't pay maintenance, you don't get firmware updates. With a MikroTik router, you buy the device and you can, well, as far as I'm aware, keep on upgrading until it's basically a dead device. Features like the ability to change the bucket size that was in 6.35, that was a massive improvement that possibly didn't impact a lot of people, but it helped us a lot. And I have to say, kind of gave the finger to those companies that say you have to do shaping in hardware. And of course, the price point is fantastic. I don't know of any other product that can do what the MikroTik devices can do for that price, especially the CHRs. I don't know if any of you have looked at the pricing for it, but if you only want gigabit interfaces, $45 is a once-off fee for a CHR that you can chuck however many ports the virtualization platform allows at it and so on, is a bargain. So that's all I've got as part of my presentation. Anyone got any questions? Yeah, down the back.
With the bandwidth management on the queues, are you using PCQ at all, or is it all simple queues?
The Flinx default, actually, when it's creating those queues, uses the queue type of PCQ. So while that doesn't necessarily benefit TASMANET, the individual customer at least will get the benefits of PCQ having the different traffic flows, each getting some bandwidth, rather than having one service be able to flood the whole link.
So the way you configure it, like under one of the headers, then the customers in that bandwidth tier are getting similar bandwidth allowances?
I'll have to actually check. Like I said, Flinx automatically configures PCQ by default. Flinx actually has 3 or 4 different ways of doing the queues that you just choose from a drop-down list. One of them is using queue tree, another one is simple queues and simple queue tree, and also PCQ. So instead of having all of those services listed as individual queues, it can do PCQ and give the bandwidth that way. We haven't found that a single NBN service can take over all the bandwidth available in a contention group or the like. But that could be because we just haven't hit that limit considering the actual amount of bandwidth that we've got available.
More questions?
Damien?
This is probably a Dorothy Dixon, but anyway. Just curious, one of the things that we found is the number of queues, simple queues that you can put on a single CHR before things go nuts. And I'm wondering, have you hit the limit where you're running more, you're having to put more CCRs,
yep.
Sorry, CCRs, just simply because you can't run 5,000 queues on a CCR?
We currently have multiple CCRs. We haven't run into an issue where the bandwidth, where the CPU usage has caused any significant issues yet. There is a limitation which I forgot to mention as part of my notes. On simple queues, the target field, I don't know if you noticed, but in the queues, if I go back here, in those queues, the target field has a list of IP addresses. It uses the IP address to target the individual services. So the top level queue of a contention group lists all of the IPs of all the queues under that. There is a limit to that field. You can only have up to 128 entries in that list. But in that case, you just need to create another contention group and then spread the load across that. That's the only limitation we've seen in terms of the way we're doing the queues. We haven't seen CPU issues. I don't know at what level we might see CPU issues, but we certainly haven't hit it yet.
More questions?
Just out of curiosity, what is NBN using to rate limit?
They've got the Nokia gear, don't they? The Alcatel Lucent equipment, 7750s or something like that. Yeah. Yeah, the key thing is that they're policing the traffic, and as far as we're aware, the justification is they don't have enough buffers to support everybody, so they don't give buffers to anybody, which, yeah, puts more work on us as RSPs. But
more than that, they actually don't want you to hit those policing. Don't you get an email from NBN when you start hitting those limits? Like they actually really say you should not be using us as policers, you need to do this yourself.
Yeah. So for those who couldn't hear Damien, NBN have reports that they generate, and if you're hitting their policer a lot, it will trigger an alert. They don't want you hitting their policers, they want people to shape it themselves. I think when we were at the NBN test facility, one of the guys there mentioned they originally did do shaping in at NBN, however, they stopped doing it, I guess, once they reached more and more RSPs putting load on their systems. Any other questions? Over the back? Yeah.
OSPF, you haven't mentioned OSPF at all. Are you using BGP for like inter-router connectivity or OSPF?
For our NBN internet routers, we have BGP, which connect to our transit routers to then get out to the internet. So it sends the /32 IP addresses for routing and so on for that. In terms of OSPF, we don't use it in our telco network like that. We do use OSPF in areas where we've got MPLS configured in bits and pieces. And we have had OSPF running over an NBN connection as well, as part of that.
Yeah, no, that's not what I meant. I meant like between the routers for connectivity between the services. So the different sessions, to have sessions in different states or different POPs or different routers to be able to connect to each other, to use OSPF for that, or?
Well, we're using BGP for that. So those individual IPs are all in the route tables of the intermediate devices so that it knows which router has which IP. Yeah.
Sorry, wait for the mic.
So do those /32s all wind up in the global BGP table, or are they sort of compressed somewhere?
They're all listed individually in the route table on our core routers. We don't transmit them upstream. Oh. No. So in general, for most upstream providers, you can't advertise less than a /24 anyway. But we would never intend to, because we have our transit routers at the border of our network that aggregate all of that anyway, so they know the path to them. Okay. Any other questions? Yeah.
If you were approached by the NBN who said that we want to just start again and do it all from scratch, could you just spend a couple of minutes talking about perhaps how you might approach it in the light of the experiences we've had to date?
While I work in a telco, I haven't really done stuff at the scale that NBN have to deal with. I don't think I necessarily have the experience to be able to come up with a better design. I know there are some simple things I would love to see, like fibre to the premises everywhere, not just to where there happen to be politicians living and so on. But yeah,
Can we call you Mr. Internet?
I don't mind what you call me. So yeah, so unfortunately I can't really answer really what I would say in terms of what might be a better way of doing it. It's on a very different scale than what a lot of us deal with on a day-to-day basis. I think being an actual national level system and trying to be everything for everybody is not possible.
Thank you.
So. Anyone else? No? All good? Thank you, everyone.